Hi everyone, my name is Ledesma from BECCE 3B, and this is my presentation on ECE 23 performance test number 8. So, the objective of this presentation is that by using binary machine in order to compute for entropy or H, using probability method and using Hartley equation or Hartley function, and comparing the two results and which of the method is more convenient to use. So, here's the first method. So this is the binary machine for case 1. So in this case, so it has 7 possible outcomes. So for case 1, question number 1. So is it A or D? So is it A or D? So 1 represents as yes and 0 represents as no. For yes, so AD, is it A? So is it A? So for yes, it's predicted as A. So for no, it is D. So let's go to this part. It is has an outcome of no, which is no. Is it A? So A we predicted as, for the yes we predicted as a E. So for the no, so is it Y? So Y, if yes, so we predicted is as Y. And for no or 0, so M is the answer. So is it M? So for yes, the answer is M. And for no, the answer is I. So it is I, or the answer is I. So we ask for it is it I? So for yes, we predicted as I, and for no, we predicted as L. So we go to this path. So the answer is 5. So total is 5 question and that's 5 bit or 5 bit. So for its probabilities, for A, represented as 0.25. So for some knowledge of this, for binary machine, so for the first level, so it has a probability of 0.5. So we'll just divide for the second level, 0.5 divided by 2, so it results as 0.25. For the third level, so 0.25 divided by 2, so it results for 0.125. So the same with 0.625 and 0.3125. Also, it is depends of how many level, if it is dependent on its possible outcome. So probabilities, so for A, this is equals to 0.25, so D is 0.25, so E is 0.25. So we will just look for its binary machine by its level. So A is 0.25, D is 0.25, and E is 0.25. So for I, so I is 0.03125. So this is I, 0.3125, and L is 0.3125 also. So for M is 0.0625. So here's the M. So the M is the only letter that has a probability of 0.0625. So for the Y, so Y is 0.125, and Y is also one that has 0.125 probability for each probabilities. For number of bits, so for A it equals to 1, 1. So for A, we will just look for its path. So we look for its path where it goes. So this is its path for the A. So 1 and 1. So number of bits is 1 and 1. So for D, this is 1 and 0, so 1 and 0 for D. For E, it is 0 and 1. This is the E, so we look for its path 0 and 1. And for the I, it's equal to 0, 0, 0, 0, 1. For the I, let's look for the I. This is the I, so we look for its path 0, 0, 0, 0, 1. For the L, 0, 0, 0, 0. Here is the L, so we look for its path 0, 0, 0, 0, 0. For the M, so we look for M, so its path is 0, 0, 0, 1. 0, 0, 0, 1. For the Y is equal to 0, 0, 1. So here's the Y, and its path is 0, 0, 1. So now we will solve for its entropy. So entropy is represented by letter H. So H is equal to 3 times 0.25 times 2 plus 1 times 0.125 times 3 and plus 1 times 0.0625 times 4 plus 2 times 0.03125 times 5. So it results for the H is equal to 2.4 bits. So where these 3 come from? So 3 is the number of probability for this A, D, and E. So we look for this same probability, so we'll just represent as 3 because it has the probability of 0.25. So for these 2, this number 2, so it represents 4 number of bits. So for 0.25, for those who have a probability of 0.25, so it is represented by 2 bits, 2 number of bits. So 1, 1, so 1 is 1 and 1 is number 2. So it represents as 2 number of bits. The same for this equation for 1 and 3. The same. So it is 1 is represented by 1, 0.25 probability of Y, and for 3, so it represented as number of bits, which is for 0.25 it has 3 number of bits. The same with this and this. So it results for 2.4 bits for its entropy. So here we will use the Hartley equation or function, which is this equation. So we will just use it to calculate its entropy. So we'll just follow the equation, reference equation. So 3 times 0.25 log squared sub squared, so 0.25 plus 0.125 log squared, and 0.125 plus 0.0625 log squared, 0.0625 plus 2 times 0.0325 log squared, 0.0325. It results for 2.6 bits for its entropy. So we will proceed for the second equation. So here's the second equation. This is example number 2. So we use the same possible outcomes, which is A, D, E, I, L, and Y. So for case number 2, we do different kind of binary machine on how we represent it. So here is the binary machine. So for case number 2, question number 1, so is it A or D or E? So is it A, D, or E? So for yes, so it has an outcome A and D, A, D, E. So for A, is it A? For yes, so A is represented by 0.25, and for no, DE, so the possible outcome is DE, so we choose D. So is it D? So for yes, we predicted as D. So represent as a probability of 0.125. For no, it is E. Same with the same probability of 0.125 for E. So we will go to this path. So for no, so it represents as I. So is it I? So for I, we predicted as I. So for yes, it is I. So it has a probability of 0.03125. For no, so it has a possible outcome of LMY. So it Y. So Y for yes, we predicted as Y, and probability of 0.125. For no, so for no, it has a possible outcome of L and M. So it is M, or is it M? So for yes, we predicted as M, represented as 0.0625, and for no, represented as L. So L has a probability of 0.0625. The same procedure on the example number 1, which is 0.5 for the first level, we divided into 2. So for the second level is 0.25. And same with the last level, which is 0.0625. So the answer is L. So total number of question is 4. So it has 4 bit of question. So its probabilities for A is equal to 0.25, which is shows it's on its binary machine. In the binary machine, which is A is equal to 0.25. So for D is equal to 0.125, which we find D, and its probability is 0.125. For E equals to 0.125, I equals to 0.25, L is equal to 0.0625, M is equal to 0.0625, and Y is equal to 0.125. So for its number of bits, for A is equal to 1, 1, because its path is goes to 1 and 1. For D is equal to 1, 0, 1, so we look for its path. For the D, which is here, so we look for its path 1, 0, 1. For the E, it's equal to 1, 0, 0, which is the E, we look for its path 1, 0, 0, 1, 0, 0. And for the I, it's equal to 0 and 1. We look for the I, so its path is 0 and 1. For the L, so L, we look for the L, so we look for its path, so 0, 0, 0, 0. So for the M, we look for the M, so its path is 0, 0, 0, and 1. So for the Y is equal to 0, 0, 1, and here's the Y. Y is equal to 0, 0, 1. So the same procedure for each entropy. For each is equal to 2 times 0.25 times 2 plus 3 times 0.125 times 3 plus 2 times 0.0625 times 4. So H is equal to 2.6 bits. So same also, 2 is represented by 2, 0.25, which we look for in here in the binary machine. So there are 2, 0.25 possible outcome. So set by 2 probability of 0.25. So 2 is the number of bits, which is represented by 1 and 1. So 1 and 1 is also 2 number of bits, 1 and 1. So for 3 times 0.125 times 3, so 3, so there are 0.3, 0.125 probability, so 1, 2, 3, so represented by 3. And for the 3, it represents 4 number of bits of 3. 3 number of bits, which is this. 1, 0, 1 is 1, 0 is 2, and 1 is 3. So with this number of bits and probability, so the result is 2.6 bits for each entropy. So next we will use the Hartley equation to find its entropy. So we'll just follow the procedure and its reference for each equation and here's the equation. H equals to 2 times 0.25 log squared 0.25 plus 3 times 0.125 log squared 0.125 plus 2 times 0.0625 log squared 0.0625 is equals to 2.6 bits. Same with its entropy. So as we compare the two methods in finding its entropy and probability, so the more convenient method that we use is this binary machine number 2 because we use less representation for its binary machine and much lesser questions, total questions and probabilities, and much more lesser equation to be used in its finding its entropy and for its Hartley equation. So that's the end of my presentation.